We are now back here at our Forestry 101 lecture series, and I warmly welcome Andreas Bolte. He's from the Thünen Institute, which is right here also on the location, and I think he will tell you more about himself. Thank you so much for being here.
Yes, thank you. Good afternoon. It's really a pleasure for me to be with you here. I've also a certain history. 30 years ago in 1992, I was also on an excursion in the Czech-Slovakian Republic. At that time, they just want to go to Terra Park, to both states. So I have quite nice memories on these excursions. And now also I'm not only the head of the Institute of Forest Ecosystem, the Thünen Institute of Forest Ecosystem, which is a federal research institute here in Germany. Okay, yeah. It's a federal research institute, but I'm also active in UFRO, the International Union of Forest Research Organization. I'm organizing a UFRO task force on transforming forest landscape for future climate and human well-being, very much in focus on forest landscape restoration. And in this task force, we are collaborating also with the UFO task force, the ISHA task force on forest education. So I have several links, but now I was asked more or less, or kindly asked, to tell something about the situation of the forest in Germany. I heard that you already had an excellent speech on the question of forest management. So I will focus more on the question of the recent mortality dynamics. So the title is Forest Mortality Dynamics in Germany and beyond, because not only Germany, but also the neighboring states are affected. And the question, how can we cope? And this presentation is also prepared by my colleague, Tanja Sanders. She is the head of our forest ecology unit and, directly within the staff of forest monitoring. Yes, I would like to start with a few on the forest damages, the serious forest damages, what we had in the last years, 2018, 2022. This year is a bit better, perhaps. And would also like to discuss with you about the adaptive potentials of forests to environmental change impacts, with the focus on Germany, of course. And would like to present some ideas on adaptive forest management. Perhaps, Peter, you already have perhaps mentioned it before. Really to change the forest management towards more resilient forest and also more adaptive forestry in future. And last but not least, I would like to draw some conclusions and discuss with you according to some key messages. So my idea is also that we are looking on a few slides and discuss afterwards. To just not only half an hour of presentation, but I also have some breaks in between and we're able to discuss. And if you have any question, please raise your hand and ask something if you think I don't understand something or something like this. Yeah, some facts about the forest and forest damages in the last years. So you can see the picture on the left side is on the Harz Mountains, which is one of the seriously affected areas in Germany. Large areas of the spruce-dominated forests are gone. This is within the national park, so no management in the national park except of the bark beetle management, what we have there. And down you can see some heavily affected beech trees near to our campus. You can see the trees even if you go out here for a small distant walk. But the important point is these two species are by far the most important species what we have in Germany. Why? So Norway spruce, according to our last inventory in 2017, covers 25% of the forest area in Germany. It has, they have 33, so 1/3 this complete standing wood volume in Germany, in the German forest. and it contains 27 of the carbon. So the carbon storage about 27%. But, and this is very important, it stands for more than 50% of the total logging volume. So Norway spruce is by far the most important commercial tree species. So many of the wood and timber industry in Germany belongs on or is dependent on the up to now to the supply of spruce timber. On the other hand, Norway spruce has only 16% of the forest area in Germany, but of course the most important broadleaf tree species, 70% of the standing wood raw volume, but also about 21%, so quite near to the carbon storage in the Norway spruce-dominated forests. But, and this is very important, 67% of the forest area in Germany would be beech-dominated forests. And in former times, where the strong transformation of former broadleaf forest, which is beech forest, but also oak forest, towards coniferous forest, in particular Norway spruce forest, but also Scots pine forest, so in the northern regions, also around here to Eberswalde. So you can see that the damages what we have, especially on Norway spruce, by far the most damage we have in the spruce forest, but also more and more in the beech forest, are really a challenge for forest ecology, but also forest management. Yeah, and here's I think, quite nice illustration from remote sensing techniques and modeling by our colleagues from the Technical University in Munich, Cornelius Senf and Robert Seitel. And what you can see in the top is the modeled summer vapor pressure deficit and the anomalies. Okay, you know what I mean. So this is not only, so summer vapor deficit, vapor pressure deficit is more or less like the thirst of the atmosphere. So this drives transpiration. And what you can see here in 2018 to 2020, that we have in sometimes more than 4 times increased thirst of the atmosphere compared to the long-term mean 1986 to 2015. And this is particularly the case if you look in the center of Europe with Germany in the center. And in the figures below, you can see the forest disturbance anomalies, which is more or less driven or derived from satellite technique or images, which shows more or less the availability of foliage in the tree canopy. And what you can see also here that, especially also in Germany, but also some part of the Czech Republic, you see the red dots. In sometimes they're 5 times higher, the anomaly, so that means the damages than the long-term mean. So you can see that drought regions correspond very well with the damaged regions, and this points also to the point that these disturbances are not primarily induced by management, of course, perhaps by management in the past, because more adapted tree species were converted, but not on the recent management. So, but looking especially on the different tree species, here, as I already mentioned, spruce, these are quite new, it's a quite new publication and results from the assessment within the International ICP Forest Monitoring Plot, the International or the European Forest Monitoring. And what you can see here are the red dots are an increase of the annual mortality, AMR, and blue are the decrease. And you can see that it's quite scattered. That means not only in entire area we have an increase of the mortality, but especially in areas where we have enough water resources in the soil, we had sometimes even also a decrease of the mortality, because if you have enough water in the soil, you have also quite good growing conditions. But on the right side in the figure, what you can see is that especially on the sites with decreasing water supply, which is more or less the blue line going down, you have an increase of the mortality. And this is the case for particularly Norway spruce, but also for European beech. So you can see the summer water deficit is more or less responsible for the forest decline in this area. There are different mechanisms behind, but you see this is more or less the basic driver are drought and perhaps also heat. So, but coming back to Germany, you can see here the climatic water balance. And climatic water balance is the difference between the precipitation here in the growing season from April to September with the potential evapotranspiration. And in the long-term mean, you can see that we have, especially in the mountainous areas, you see the blue areas. Do I have something more or less to show on, or a mouse or something like this here?
The mouse.
Okay, I see. So I hope you can see also it. So you can see here what this region are, these high elevated regions with a surplus of water. That means more precipitation, more water availability than it's needed by the transpiration. And then you can have here more or less up to now, centennial drought, 2003, so-called centennial drought. But you can see in 2018 it was much stronger, the drought, and affects entire Germany, and also 2019 and 20. So we had 3 droughts in a row, and this was, of course, the first time we had in our region. So a complete new situation. And what we also had, we had strong storm events in the winter before in 2017-18, and this delivered breeding material for the bark beetles. So one question perhaps from me to you, you know about the setting of the bark beetle. What do bark beetles need for outbreak? Some ideas? One thing I already mentioned is the breeding material. So they need dead trees or fresh dead trees or freshly dead trees as breeding material. And the other point, insects. What do you think about insects? What is needed for insects to have an outbreak? Yeah. High temperature, long vegetation, long warm periods. And this was, of course, the other point. So one ingredient was more the breeding material from the winter storms in many areas. Then we had this, in some region, 3-year drought from April or May 2018 to autumn 2020. In some areas we had really a drought area in the upper soil layers down to 50 centimeters. And so to this we had more or less multiplied bark beetle numbers. So we have 3 generations, sometimes 4 generations of bark beetle, and this is more or less like a strong increase, of course. And this is the other point. The spruces are dependent on enough water resources to activate their defense system. And the defense system is due to resin. So they more or less kill the bark beetles, would try to drill in with resin and to fix them and to kill them. But without water, they were not able more or less to activate the resin production. And this was more or less the 3 ingredients. So enough breeding material for the bark beetles, we have the warmth, and we have the drought affecting more or less the defense system of the spruces. And this was the cause of the large area outbreak, what we had in, I think, nearly all of our so-called spruce regions in Germany. And here's more or less then the consequences. So the tree status and forest damages. And what you can see above is more or less the mortality rate according to our forest ground conditions survey. You can see in all the time from 1990, last 30 years, it was below 1%. Sometimes only 0.2 or 0.3% for, I think, nearly all of the tree species, major tree species, which is spruce, pine, oak, and beech. But then we had this tremendous increase to sometimes 4.3% and 4.4% in 2020 and 2022. And what does it mean, 4%? If this would more or less would be more the same in the following years, after 25 years, you had no one single spruce tree in Germany. So this is very important that we have this very, strong increase in the mortality rate. But also other tree species were affected. So also pine, less than oak and beech, but even oak and beech have an increase of 100% or sometimes 200% of mortality rate. But with spruce, we have more or less about 4,000% or something like this. So, and what you can see here, down here is more or less the amount or the share of damaged wood in total logging volume. So which logging volume is due to damages? And what you can see here are the pulses here. The black line is the total share. You can see the pulse here and pulse here. And this was in the past always due to strong storm events. So we had an hurricane called Vivian Wiebke, or 2. Then here we had the hurricane Lothar, Kyrill in 2017, and so on. And it's interesting that the blue columns always link the share of the storm damaged wood. You'll see that always when you had a pulse here, you had a strong amount of storm or uprooted timber or trees delivering timber. But this changed dramatically in 2018. So at first you have no one pulse in 1 year. So you have 3, 4, 5 years in a row with more than 50%. Which is, of course, extremely high. And on the other hand, you have a high insect column here. That means this is all driven by insect, and it's a complete change of the disturbance regime. So the most problematic disturbance in the past, until 2017, were storms. So very much was also focused to get the forest adapted to storm events, to resistant to storm. But now we have a complete change to that we need more forests which are resistant to these specific insect attacks, which is not only, of course, one bark beetle species, but also a certain variety of insects. Yeah, and here's a view also on our neighboring countries. You can see that, of course, Germany, but also Czech Republic is in the center, looking at the damages. Both have a high share of spruce forest. And you can see, and this is the figures only until 2020. So we have now even more, 170 million cubic meter, which is about 15%. Now we are talking about 25% of the total volume, which is affected by these damages for entire Central Europe, or it's only 10%, or EU is only 10%. But you see that only other neighboring countries are affected: Austria, Czech Republic, Slovakia. Interesting also Poland, because Poland has a majority of damages in Scots pine, also to a Scots pine bark beetle, which is spreading there. But one point is very important, according to my view. We have still 80% or 90% of spruce forest left in Central Europe. We are very much focusing more or less on the damages, high damages, but there are so many spruce forests still growing and living. So what we can do with them? I think this is an important question. So do we have some question to the figures? Are you familiar with the situation? Do you have similar situation perhaps in your home countries? Where you come from? We have 2 micros, or?
Okay. Are you hear me?
Yeah.
Okay, thank you.
Yeah.
In Mexico, we have many animals, insects The name is barrenador, and it's very few problem in this country because this species of the insect, it's very hard for the wood, and the wood when we are export in other countries, this wood it's the best quality, I think. And I don't know what is the species of the insect affect the trees of the in here. I don't know what is. Oh,
It's a bark beetle which was drilling down into the bark and then more or less cut off more the cambium. And due to this, the trees are dying. So at first, more or less the roots are dying, and then more or less the entire tree is dying.
thank you.
Yeah, thank you. Yeah, of course, this is also my perception that we have quite in detail different, but in total also often really problems with new vitality and impacts of insects, but also other pathogens. And this is, on my point of view, linked to two aspects. One is really then climate change, but also sometimes also international trade invasions of different pathogens and so on. Perhaps you may ask why I'm not talking about forest fire, because this was also a discussion what we had and a problem in the last years. But looking on the area, forest fire in Germany is less a problem than, for example, the insect attacks that we have. But forest fire might get really a big problem, because forest fire is not only damaging forests, but also all the infrastructure, villages, people have to go out and so on. And this is, of course, more also a threat, an increasing threat that we have also in Germany. So we think also about the question how to combat forest fires and to adapt the forest to new situation with a increasing fire risk. But now perhaps to the second part, adaptive potential to environmental change impact. So what can we do? So thinking now we have the problems with lots of spruce forest at risk, but also other forests at risk. But how can we deal with this? Here's the projection of damage risk status. So now we have seen more or less what was in the past, 2018 and so on, and 2022. Now it's a projection into the future. And what you can see on the left side is always, it's again always spruce. And here's more or less all the area, and the dots are inventory plot. We have 60,000 inventory plots in Germany, and these are more or less 4 plots more or less in a bundle, and these are more or less one central plot here in Germany, covered with Norway spruce. And according also to the discussion with forest practitioners, they say, okay, the stands below 600 meters of sea level, because they are normally also warmer and so, and often more exposed to drought, it's difficult to control bark beetle outbreaks. So they say this under the altitude of 600 meters, difficult to keep the stands intact if you have Norway spruce or Norway spruce dominated stands. If you more or less use this as an indicator, you can see that about 70% and more or less sometimes entire regions here on the northern part, which is more or less lower than 600 meters and so on, are affected, which is in Germany 2.2 million hectares. Entire forest area in Germany is about 11 million hectares. So 2.2 million hectares means 70% of the entire Norway spruce covered area, and also the same for the wood volume by Norway spruce. And on the right side is European beech. So European beech up to now seems to have a lesser problem with, primarily affecting pathogens, but more or less just more or less with a physical drought. So just more or less are wilting. And this is, of course, the point on areas where you have a low water storage capacity, perhaps shallow soils, high or bedrock soils, and so on. And this means that, we can look more or less at the geology and the soil situation, and we can more or less then link this with a soil water capacity of less than 90 millimeters, which is quite low, until 1 meters of soil depth. And if you more or less combine this, you have a certain situation that we have about 30% of the European beach stands which are at risk, which means 1/3. So in total, we have about 2.8 million hectares, which is 1/4 of the entire forest area in Germany. And if you have the idea to transform these 2.8 million hectares of forest into more adaptive or adapted forest, until 2050, you need 95,000 hectares per year transformation area. So up to now, we have a bit more than 20,000. You need more than 4 times the area per year. And this costs lots of money. Together with our colleagues of the Forest Economy Institute, we calculated about 13 to 43 billion euros. And now we have also some budget cuttings in our public, on the federal finance system. So now the discussion, do we have the money? Our government is also now willing to promote more or less forest transformation. And this is, of course, now a quite tricky debate what we had, also with the Forest Owner Association, nature conservatives, and so on. But then one thing is very important. Forest transformation does not mean that you have to actively transform the stands. You can use also nature regeneration, but you have to look on it. If you have, for example, a spruce stand, which is at risk, and you have a nature regeneration mainly by spruce, then it's perhaps a not so good idea to let nature regeneration go. But on the other hand, and sometimes you have really a change by natural dynamics into more adaptive tree species composition in the forest. Yeah, and what we have, we did some research on the question. If you think about forest transformation, I think 95% of the people are thinking of replacing one species with another, or one species with a mixture of species, or a mixture of other species. But there might be also a possibility to look on the different provenances. And do you know what provenances are? You heard about it? Provenance are just more or less population. You have the entire range of a tree species, for example, European beech, from southern Scandinavia down to South Italy and northern Spain and to Greece and so on. And to think about that, if you go on the margins and the boundaries, in the southeastern boundaries, where you had also in the last decades or centuries already drought events, the individuals and the populations may have to be able to adapt to these conditions by selection. That means all the trees which are able to adapt, they survive, and they give their gene pool to the another generation. And so you have a more or less a movement towards higher adaptation. And this is the idea to take those provenances and to transform it to other areas where have an increased drought damage in the future, or drought pressure in the future. And we looked on these potentials for European beech, for Norway spruce in the top here, and European beech, and it's interesting that quite different. So for Norway spruce, we found quite low variation. And I have to explain it. We really killed the trees by drought, so seedlings, so 1 or 2 years old seedling. And what you can see here is more or less the soil water availability in the pots. They're going down. At a certain point, the tree starts to die. And you can see here more or less that this is here quite steep, so it's only a few percent of soil water availability, which decides if a tree is able to live or if the tree dies. And this is quite narrow here, the variation for Norway spruce. So the option to use different Norway spruce provenances to adapt to spruce forest seems to be quite limited, but this is quite different for European beech. So you can see here that the variation where, for example, 50% of the population is dying is quite different. These are more or less this indicator, LD50, I mean lethal dose, where 50% of the population is dying or has died according to the soil water availability. And this is quite here for Norway spruce, it's quite similar numbers, but for European beech, it's quite different, 7-8%. And this means sometimes 2 weeks more tolerance of drought for such a seedling. So this seems to be perhaps also an interesting point, but this is also important. It's of course compared to the options and the tolerance of other drought tolerant species. This is also quite limited, but is perhaps also a certain option. Yeah, and the other point is also if you're looking on adult trees, you can use also provenance trials. This is also analysis of above provenance trials on the growth. So we're not more or less trying to kill adult trees, but just more look on the growth response on drought. And one point is interesting is also Norway spruce, that on moist side, all provenances increased if you compare more or less the future growth simulation with a calibration period in the past 1986 to 2010. But this is not very, astonishing, because the growth condition, if you have enough water resource, is better because the growing season have prolonged and the option for photosynthesis and so on is also increased. But it's more interesting to look on the dry side. So you see a negative response for all, but one provenance is different. So this might be also one point, that you really look in detail on the provenances. But, and this is also one limitation, this is only the tolerance against drought, not a tolerance against late frost, against storm and so on. So it's very important to look on the multiple conditions, environmental conditions, what you have. So, but there might be also a certain potential for drought adaptation by provenance selection. But this is, of course, really a frontier also in research, what provenance provide which option. And do we have really a benefit compared to the natural adaptation? So it's, I think, very important to look if natural selection or natural dynamics provide the same. I think that's not worth to go with a high, with high efforts on tree species selection, to provenance selection, but more or less then let nature do the job. So, but what about adaptive forest management? Adaptive forest management, and perhaps here some terms that we can also discuss about it. I think it's important to think that forest ecosystems are more than a bunch of trees. So forest ecosystem, an ecosystem had very many loops and internal cycle, multiple cycling and so on, and energy and nature and water processes. So ecosystem adaptation is a complex process dependent on ecosystem vulnerability to drought, to storm, to heat or what else. Resilience and dynamics. And resilience is also quite complex, but because resilience means only several of the tree individual can die, but the entire forest can survive. So this means that we have to look not only on the tree level, but also on the ecosystem level. The other point is the question of adaptation in terms of management. So you have active adaptation, which means planting trees, cutting trees, what else? Tending trees and and species stands. But we have also these passive options. That means also nature is going in a certain direction. The point is not at the end, because we have a strong speed of climate change, if the natural processes of adaptation are sufficient to more or less keep the forest intact. Or are there any barriers in it? We can also discuss about this. Like, for example, if trees are expanding, they're not able to go over large agricultural areas or industrialized or settlements and so on. So active adaptation, as I already said with the example with the spruce, would be perhaps a good option if nature is not able to change the tree species if you have a high sensitive tree species. So then active adaptation might be a good choice. But this is also important to address the environmental stressor. But, and this is also important, also the societal, economic, and technical change. So we also discuss about not only climate change, but global change. And adaptive forest management also provide a dynamic approach. That means you have to rethink about it. You have to change also. Not, in former times, perhaps Peter Spartev, there was a strong planning. So you have a certain stand, you have a plan for the next 100 years. So at 20 years, you do this thinning, and that's clear. And at the end, not you, but you're more or less the next or other generation will then harvest exactly more or less according to the plan. So this was the idea. But now climate and global change is completely more or less changing the conditions. And so we have to be adaptive also with the management. And this is the idea with the concept of adaptive forest management. If you think at the really quite naive, what I'm managing or where I'm managing, they're the biophysical conditions. So you have the site, the soils, the stand structures, and so on. This is directly impacted by climate change. So we have more heat, drought extremes, and this is also need to be monitored. So you have to look at what's going on here. Not only the climate monitoring, but also more or less the response monitoring of the trees. This is also a matter of monitoring and science, of course. But then, and this is very important, what for? And this is also changing. So the ideas, what for the trees are managed are changing. And this is not only the idea of the forest owners. So forest owners perhaps in the past are very much focused on timber production and so on. And perhaps also in the future, perhaps also more on ecosystem services, water purification or something like this. But also a huge and increasing number of stakeholders, like, for example, nature conservists or entire society. If you think, so I know when I start with work in 1990, in the early 1990s, really only a few people talked about the carbon and the climate protection function or service of the forest. Now it's more or less one of the top ecosystem services. So this is, of course, a change within only one tree generation, 20, 25, 30 years. So we need also the monitoring and science on this. What do future generations want from our forests? And then we have all the third question, how we are managing, and think about the progress, what we have, not only machineries, drone seeding, for example, or remote sensing techniques, artificial intelligence, which is also very much then changing also the matter how we are managing the forest. And at the end, you have such a certain loop here, because after a certain time, this will have changed. You have to adjust. So after perhaps 10 or 20 years to think again, what for, how the biophysical condition have changed. Do we have new techniques, new machineries, and so on? And this is more or less the idea of adaptive forest management. It's quite complex and it's really demanding. So, and this is also a kind of the thing in education. So, in former times, you have a clear picture and it sees we have a more constant environmental conditions. But this has changed. And the point is we only have high variable social conditions. So we have new ideas, new concepts, and this has to be integrated in the concept of adaptive forest management. And it's an open concept. It's not, seen scheme 1, 2, 3, but more or less, it's just more or less a philosophy or an idea than just a complete or fixed concept. And one idea, and this is perhaps linked also to the question of, for example, provenance trials and so on, is the idea of assisted migration. So assisted migration means that we try to help species, or not really species, but genes to migrate through the landscape. So, and there are perhaps 3 different elements. On the left side, what already was mentioned is the transfer of provenances. So taking beach provenances from the Balkany towards Central Europe. So, but this means at the end, there's no really a change of the species composition, but just more or less a change of the gene pool. But this may, to a certain limited extent, would help, because this gene flow, during the high speed of climate change and fragmented forest landscapes are not able. So one question perhaps, after the last ice age, do you need the speed of beach per year to come back to Central Europe? So perhaps for all of Central Europe and this area was covered with glaciers. There were no forests 12,000 years ago. And then in the last 12,000 years, more or less, our tree species come back from refugia from the south. But if you think about European beach, do you know the speed of European beach? One idea, perhaps one guess also. You have a suggestion? Yeah, 200 meters, 300 meters in 10 years. So that means 30 meters in 1 year. So, and think about the climate change, what we have now. We have sometimes several kilometers in 10 years. So I think about between 12 or 15 or 20 kilometers of more or less changing climate. So, and especially European beech has also the big nuts, the beech nuts. And so all the trees with heavy nuts, it's also oak. Some of them are really transformed by animals. But if they are just more or less by physical means, they are not able to have to perform such a high speed to can follow the changing habitats of them. So, and this is more or less also the idea of assisted migration to look on it. So we have no problem with birch tree, for example. They spread more or less for perhaps several hundred kilometers, because they have really seeds which can be, which can be transported with the wind over long distances. But all the heavy, with the trees with the heavy fruits, they have really problems. So this is one with the transfer of the provenance. The other idea is extension of species range. We have some tree species, also in Germany, other part of Central Europe, we're just not looking at the door. Balkany oak, for example, downy oak, some others, where we already see a tendency that they're coming more or less towards north, and to help them to get even more towards north with a higher speed in regions where are not native in the moment, but would be native in the future. And the third part is the most discussed one, is the introduction of exotic tree species from other continents. So in Germany, we're discussing about Lebanon cedar, Atlantic cedar, and other tree species. But then there's a serious discussion, a really important discussion about the potential of invasiveness, which means I think it would be not a good idea to, without testing, to import exotic tree species. And at the end, they are more or less outcompeting the native tree species or other more or less tree species which are coming into the area. Because at the end, it's important that we achieve and to preserve a high variety of tree species. Because this is, of course, important because every tree species, every provenance has a certain demand and a certain potential to adapt to environmental conditions, and we have to keep this. And as I already mentioned, due to the Ice Age, we have quite limited tree species number. In Central Europe, in Germany, it's discussed about 60, 70 tree species. For example, in Northern America, we have several hundreds, and also in the same in the temperate zones, and also in East Asia. So we are quite poor with tree species. Point we have to think about it. What are the potentials within our quite species poor area? What we have here in Germany, and anthropogenic impact also decreased in many kinds, in many parts. Also the variety and species number or the species composition. So at the end, if you think about the option, that means help the trees which are expanding their habitat towards north, but perhaps also the provenances, keeping and increasing the variety. And I think I should also mention, we have many native species also. Among the 70, we are only using for commercial purposes perhaps 10, not many more, 10, 15. But the other 40, there are several also interesting species which are more or less neglected. So, and really to look on the potential of these species like Acer species and also fruit trees, native fruit trees, what we have also in Germany. And so to really get a higher variety of tree species and increase the gene pool at the end, that's very important. So, and one point is also thinking about adaptive forest management. Management, I don't know what your perception is, are many very focused on one stand, local. So really look on the local. This is the stand and the site conditions and so on. But if you think about the assisted migration and adaptive forest management, you have to widen your view. You're managing regions to make them more transferable for genes. And this is also important. So at the end, we have to collaborate also with the agriculture sector, the settlement sector, and so on, and to think about the entire concept of managing species migration at the landscape and the regional scale, sometimes perhaps among entire continents. And this is also important, and also discussion that we have to integrate the different land uses also. Think also the kind I just mentioned, also agroforestry and so on, and woods outside of the forest and so on. So now coming to my conclusion and key messages, and we can also then discuss perhaps about them. I hope I could convince you that the adaptation of forests to climate and environmental change is one of the key challenges in this century. I'm really convinced that without forest and forestry adaptation, we are not able to reach the ambitious climate protection goals, both in Germany, but also not in the European Union. And I think this is also a responsibility that we have also for the world. So I think climate protection and forest adaptation are more or less is completely linked. I'm really convinced that we need new concepts like adaptive forest management, or theories, perhaps not a really concept, that we really have an idea about forest transformation, not as just one step or one procedure, but like a process. So forest adaptation under terms of climate change will be a process, will perhaps never end in the next centuries. Because, even if and I hope that we are more successful with climate protection, the effects will last for the next centuries. That's quite clear. And it's very important, we should not only look on climate change, but also the change in the social and the technical conditions. So new techniques, but also, so we don't know what our children or perhaps their children are, want from forest as ecosystem services. So we have to think about it and we have to adapt to this. It's not easy. And I think assisted migration is a key element, or could be a key element. Because I think one of our problems are the fragmented landscapes. So the connectivity of forests and the possibility to provide corridors for genes to migrate through the landscape is a really essential essential frame for more or less adaptive forest management. And adaptive forest management, including then also not only active, but also passive elements. Yeah, and now we're coming more or less exactly also, to your issue, international collaboration, also in education, in science, and so on. It's really important, not only throughout Europe, but also worldwide. Why we need to step from this idea of local management. So everybody is doing this, his or her locality, but also to think more, to open the view on regional international management of species ranges. There's many things to do, for example, seed legislation. So, for example, in Europe, I've learned, we had also a research project, that every country in Europe, Hungary, Austria, Poland, Czech Republic, Slovakia, has its own system of seed legislation to more or less to look different seed zones where the different provenances are delineated and so on. So, and we have really, we have one, I would say, trial system to combine it for Europe, but this is not working very well. And of course, I have a colleague in the Czech Republic, and I say for Czech foresters, it's not possible to import any seed or seedling from outside Czechia, which is of course a catastrophe if you see that half of your spruce forests are gone and you have not the seed capacity, not the nursery capacities to get the seeds and so on. And this is also a point which is very important and a question for collaboration, also on a political level. Yeah, and political action on regional, national, and national scale has already started to implement forest adaptation within climate protection strategies. So in Germany, we have, for example, quite new the Climate Action Plan and so on. And we're discussing also to give specific funds to forest owners who are trying to adapt the forest and to follow ideas of increasing climate protection. But this has to be more and more increased. As I already said, we need about billions of euro just more or less for this forest transformation. And this is, of course, only the money which is needed for the transformation action, but all the science behind, all the political aspects, all the thinking about associative activities are not financed by this. So I guess one of the most important points, in the forestry or forest sector, it's really more or less to gain the to be able to convince also the decision makers that this is very important to do and to do it now, not in 10 years, not in 20 years, because the window of opportunity, I'm really convinced, will close latest in 2050. I think then we have quite less options, more or less, to adapt the forest to climate change. And then we're talking really about the future of the forest in large parts of Europe. And also, I guess, also worldwide. And so I would like more or less to end with the idea and also the statement that's up to us, up to you, also especially in a future generation, really to get the power and to more or less convince decision makers and to say this is important. forests are not automatically there. We have to tend them, especially in the terms of global change. I think this is an important point. And with this, I would like to thank you. And now I beg for your questions.
Hello. Yeah, no. So my name is Jair. I am from Costa Rica, and I know that you gave a presentation more about like the management, but what about the industry, like the adaptation of industry? I imagine that right now the industry is focused on spruce and beech, but in the future there is going to be a more diverse supply of wood. So how is the industry adapting for the future supply of wood and demand of wood products? Is it happening right now, or how is it?
Yeah, this is a very good question. I think it's partly happening. So I think from my point of view, there are two strategies. One is that, some parts of the industry said, oh, we don't get enough material, so spruce timber. We go to another region, we go to Brazil and looking then, establishing new plants with eucalyptus. So this is one idea, just more or less to follow more or less the resources the resources of the future. But we have, of course, also other parts of the forest industry really try to adapt with the change of the timber, which is more or less used, but also with the products. So we have, for example, as I said, we will change in future very much from spruce and coniferous timber more to broadleaf forest, because most of the more adaptive species are broadleaf species, what we have in Germany. And to this, there have also some ideas to have new materials and new products also with broadleaves. One point which is really tricky, that especially for timber buildings, spruce is really has many traits which are really optimal for them. So I guess, and this is one point, that many of the broadleaf species does not provide these traits. They have more or less to be treated to have the same traits, and which can be used also for timber buildings. But there's also initiatives, but this is of course really also a tough job for wood and timber industry, that they have also to adapt. But I'm completely of opinion, we need also an adaptation of the timber industry also.
My name is Jean-Loup. I have two questions. The first one is, did exist a risk that did there is a risk that okay. Sorry.
That's a good question. Yes. So if I got it right, there's a question if there's, if there are projections, or so to say, the hope that also in future large parts of Germany will be forest after climate change. Is it correct? Yeah. Yeah, this is of course a good question, and I think up to now, what I know, I'm not a specialist in this climate projections and vegetation models, but most models that I know are more or less tending to say yes, there will be no large area in Germany without forest, but we will have a tremendous change of the forest. But this is very, variable from, models which are predicting in many areas. Also in these areas, we have more or less then, Mediterranean style forests. But also sometimes to say, okay, the precipitation regime would also change, which allows also some more adaptive tree species or temperate adaptive tree species, which can resist to a certain amount of drought periods, can also be more or less a part of the vegetation. So we have, and some said they have quite novel systems, or perhaps a mix of Mediterranean or Mediterranean styles, subtropical and temperate forestry species. So, but one thing is quite what I said, that will have a change also in future. So there will be perhaps no constant situation, but if you look really along the forest dynamic in centuries, you will then have a change also in the next time. There is no, I'm a vegetation ecologist. There was always the idea of a climax. Climax, that means, but I think you can forget the climax. So there will be always a change.
In what we have to do to manage the risk of to help the forest to adapt themselves to the climate warming, and the idea to reduce the intensity of the forest management.
I think there's no one fits all solution. So I guess in this term, or in this, I think the idea is really to look on the different situation. So if you go in the forest, and of course also going around the campus, I have the feeling that there are some areas where you have a natural regeneration, which is really contains lots of tree species, lots of different tree species with different options. So this would be more or less an idea to act more extensively, to say, okay, I'm looking what's now growing up, and to think about it. But in other regions, as I already mentioned, where you have damaged spruce stands and more or less complete spruce natural regeneration, for me it's now really time to do some active management. So, and this means this would be also some intensive management. So I think at the end it depends really on the situation, environmental situation, but also the stand situation and the availability of seedlings and regeneration to decide about a different kind of intensity of management intensity. There's also here some in the. Yeah. No problem. I have also some minutes more.
Okay, then the last question is the online. Maybe you can answer that shortly.
So if the forest fire is a major concern in Germany, Clemina arborea and Tectona grandis are good fire-resistant tree species. Is there any reason they are not planted? According to my perception, both are not really frost resistant, and this is the point. And this is perhaps also one important point, what we discussed also with the use of Mediterranean species. So if you think about species, evergreen species, we still have frost and sometimes also quite strong or even stronger frost events here in Germany. That means that, all species which are not adapted to frost below -20, I would say, degrees, they're not an option. But even if there's only one event in 10 years or 20 years, this might be sufficient to kill the trees. Because I have also some colleagues from the Climate Research Institute in Frankfurt, and 10 years ago they had a large trial with Mediterranean species, and I think no single tree survived because we had two very hard frost events at that time. So the problem in the moment is really that we need trees which are adapted to the harsh climate, even also terminal climate today and in the future. I think so. That's really the challenge what we have. Oh, that's still 5 minutes.
Yeah, because I see you're all tired. It's pretty hot in here, so we need to make a small break. If there's nothing extremely urgent, I think you maybe be here 5 minutes more. If there's any question you would like to personal, thank you online for your contributions. There's just one of them wishing us a great time, and another one also having a great phrase for international collaboration. We need a more standardized methods in terms of conducting research to compare results. I agree, but this is pretty tough because we all have a lot of different applications. But of course, it's true. So thank you very much for all your amazing questions. Thank you, Andreas Bolte, for this amazing presentation. We have a small gift for you. And we're really happy you kind of came back to the roots, to IFSA, and thank you for your contributions to IUFRO. And yeah, you are invited also to join us tonight evening for the evening reception dinner. So we just have a small break now, 5, maximum 10 minutes. So go outside, get some fresh air. I try